Welcome back. This is 09, measures of center, spread, and position. This video we're going to get to center and spread, and then part 2 we'll talk about position. Here's some vocab for you. There's a lot of words in this section, so I tried to break it down by group. Okay, so when we talk measures of center, we're talking about mean, median, and mode. Measures of spread, we're talking about how far apart a data set is. Range, variance, standard deviation are some new terms to do that. And then position has to do with where numbers are in a data set relative to the other numbers in that data set. And so to talk about position, we have quartiles and 5-number summary. Another important idea with statistics is population versus sample. So this section is an intro to statistics. We worked through probability a few sections ago. Those words get put together a lot, but there is a difference. Okay, so statistics is more number-based. Probability is more like experiment-based, kind of. So there is a difference. Example 1 for measures of center, or also called central tendency, it says the number of milligrams of sodium in a 12-ounce can of different brands of regular cola are shown below. Find the mean, median, and mode. These are things you have been doing for a very long time. We have a list of numbers here in a data set. First thing to notice is that they are not in order. So the first thing you need to do is to order them from least to greatest. So starting with 10, 15, 20, 25, 30, 35, 35, 35, 40, then 50. You should have those numbers written from least to greatest. To calculate their mean, we just add them all up and then divide by the number of numbers in the data set. So there are 10 here. We're going to add them up to get 295. 295 divided by 10 tells us that the mean is 29.5. Okay. This is a Greek letter mu, this little u with a teardrop on it, and that is a statistical variable. That's the way that we represent mean. It's with that Greek letter. You say it mu. Median, if you order them from least to greatest and then keep going towards the middle, eventually you will find the middle number. In this case, we're going to end up with 30 and 35 in the middle, so we need to split the difference. And the difference between 30 and 35 is 5. So splitting that in half is 2.5, meaning that our median is going to be 32.5. Okay, that should be something you're very familiar with, which is why I'm not writing out the steps. Mode is what number occurs the most. So if we're looking at this data set, we'll see that 35 appears 3 times. So those are our measures of central tendency. And if you notice, they're kind of close to each other. So 29.5 is kind of close to 32.5, which is kind of close to 35, which tells us that this data, if we were to think of it like a bell curve, so if the x-axis were numbers from 10 to, sorry, that was my timer. If the x-axis were numbers from 10 to 50, and if we had a bell curve, then the bulk of our data, we would kind of have a peak right here in the 30-ish area. And that's what center or central tendency means. Okay, measures of spread. So measures of spread, this might be something that's new to you, the concept, but range should not be new. Range is where we take the highest number in a data set minus the lowest. And then variance is probably new. It's the mean of the squares of distances from the mean. So it's like a weighted average of how far away each number in the data set is from the mean. Okay, how spread out the data points are. And then standard deviation is just the square root of the variance. Standard deviation is a unit. So the concept here, if we think again about that bell curve, our mean is right here in the center. It's our mean. I'll write a mu. We can go a little bit out from the mean on either side of the x-axis, and this would be like the mean plus 1, the mean plus 2, and the mean plus 3, and plus 1 plus 2 plus 3 is a standard deviation. So one standard deviation is a distance from the mean. Okay, so this is one standard deviation. Okay. Variance, we refer to it with another Greek letter called sigma squared. It kind of looks like a little apple. and it's squared, and then standard deviation is just sigma because it is the square root of the variance. So this is a lowercase sigma. That is a Greek letter. Okay. This distribution, this bell curve, is called the normal distribution. It's the starting point for everything in statistics. If you take AP Stats ever, that is what you will work with. Okay, working with measures of spread. Here's our variance formula. It's a little messy. Okay, it's a little messy, but I'm only going to have us calculate it by hand one time in this video, and then I will show you in class how to use your graphing calculator to do this for you. Okay, so sigma squared, the variance equals x1, where x1 is a number in the data set, minus the mean squared, plus the next number in the data set minus the mean squared, plus the next number in the data set minus the mean squared. And then we keep going until we have subtracted the mean, subtracted mu, from every number in the data set and squared it. And we divide all of that by the number of items in the data set. Okay? And the standard deviation is the square root of the variance. So we just take the square root of this big formula to get the standard deviation. It is a unit of measurement, and it's how far away a data point is from the mean. Here's our formula for standard deviation. It's the exact same as what's above for the variance. I just put a big square root around it. Example 2. So let's play around with these measures of spread. Range, remember, is the highest minus the lowest. It's pretty straightforward. We've done that for a while in our mathematical careers. It says 2 classes took the same midterm exam. The scores of 5 students from each class are shown. Both sets of scores have a mean of 84.2. And it's asking us to find the range of Class A. So we want to find the range of Class A. Notice that these are not in order from least to greatest, so we have to do a little bit of looking. We see that 92 is our highest number, and we see that 80 is our lowest. So if we subtract those, we figure out that our range is 12. Okay. Now into variance. Same example, it's asking for the variance of Class A. So I'm going to set this up, and you will see very quickly why we don't want to calculate this by hand very often. So if we take each point in the data set, 85 is the first one, and subtract the mean from it. Our mean is 84.2, and then we're going to square it. So in this case, x sub 1 is 85 because that's one of the points in the data set, and then subtract the mean. Now we're going to do it again. Plus 76 minus the mean of 84.2 and square that. And we're going to keep going until we have every element in the data set listed. Okay, this is why I only gave you 5 numbers, because you can only imagine with a list of 100 numbers how annoying it would be to calculate this by hand. Okay, but people in the old days used to do it. Okay, and then I had to go into the second line, but this all is in the numerator. Okay, this all is in the numerator. And then the denominator, if we draw a big old division line, we're dividing by n, which is the number of elements in the data set. So 1, 2, 3, 4, 5. We're going to divide by 5. Okay. Not the prettiest thing we've ever seen, but it works. Okay, so you should be very careful here when you're evaluating. I would recommend, honestly, just typing the entire numerator into your calculator, figuring out what the numerator equals, being careful with those parentheses, addition, subtraction, and then hit equals, and then divide by 5. Okay, that's what I would recommend doing to type this into your calculator. When you do that, you should get that the variance is approximately 32.16. Okay, so practice typing that into your calculator. I trust that you're able to do that. Final question is asking, what is the standard deviation of Class A? So we're just going to take the square root of our variance. The square root of our variance is the square root of 32.16, which is approximately 5.67. So what this means is if we looked at the scores on this exam as a bell curve, and the mean is 84.2 right here in the middle, then when we go out from the mean on either side, we're going to add 5.67 to the mean. So 84.2 plus 5.67 is, let me think about this, it should be 89.87. And that is one standard deviation away from the mean. 2 standard deviations above the mean would be 5.67 above 89.87. Okay, so it would be 95 and some change. I can't come up with that off the top of my head, but you get the point, okay? So that's what a standard deviation means, and it changes depending on what the data set is. So if numbers are farther apart from each other, you're going to have a bigger standard deviation. If the numbers in a data set are really close together, you're going to have a smaller standard deviation. Okay? So we're going to break for part 2. Take a second, think about that, and then we will pick up with measures of position.